Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. If you are new on my channel, don't forget to subscribe and hit a bell icon so that you will get the notification of newly uploaded videos. So in this video, we are solving the example from question number 15 from exercise 2.2. Total 12 examples are there in this question. To solve these questions, you should have to know the interrelation between trigonometric functions and the fundamental identities. So prepare the list of fundamental identities and the interrelation between trigonometric functions so that you are able to understand this example. So let us try to solve the first example. In every example, we have to prove that the value of left hand side is equals to right hand side. So in the first example, here we have considered the left hand side, and solving this we have to prove that its value is equal to 1 upon sine square a minus sine a raised to power 4. So we have considered the left hand side. Let us simplify this left hand side. So here we can observe that 1 plus tan square a, according to identity, can be replaced by what? Sec square a. But before replacing it by sec square a, here I am taking the reciprocal of tan square. What is the reciprocal of tan square? Will be equal to cot square. So 1 plus 1 upon tan square can be written as what? Cot square a, using interrelation. We know that tan and cot are reciprocal of each other. So reciprocal of tan square will be equal to cot square. Whenever the square appears in the expression, we are able to use the trigonometric identities, means fundamental identities from trigonometry. We know that 1 plus tan square a will be equal to sec square a according to identity, and 1 plus cot square a will be equal to cosec square a. So which is equals to, as is friend, if you will observe, our required result is in terms of sine. So we are converting this expression in terms of sine and cos, because cos can be converted in terms of sine. So here sec square a can be written as 1 upon cos square a using interrelation between trigonometric function, and cosec square can be written as 1 upon what? Sine square a, because we know that cos and sec are reciprocal of each other, sine and cosec are reciprocal of each other. Now example is in terms of what? Sine and cos. So here take the cross multiplication. Let us see what we will get here. Here we will get sine square a plus cos square a. If we are taking cross multiplication, sine square a will get multiplied here, and cos square a into 1 is cos square a. In the denominator, what we will get? Cos square a into sine square a. Just simply we have taken here cross multiplication. Now again, according to identity, sine square a plus cos square a will be equals to what? 1. In the denominator, cos square a into sine square a, keep it as it is. Just this numerator I am replacing by its value 1 according to identity, that sine square theta plus cos square theta is equal to what? 1. Now to get our required result, we have to convert this expression in terms of what? Sine, and cos square can be converted in terms of sine square using identity. So here 1 in the numerator, keep it as it is. In the denominator, this cos square a can be replaced by 1 minus sine square a according to identity into sine square a, keep it as it is. So which is equals to 1, keep it as it is. Now I am multiplying by sine square a to both the term in this bracket. Let us see what we will get. Sine square a into 1 will be equal to sine square a, and minus, keep it as it is, sine square a into sine square a will be equals to sine a raised to power 4, and check that is it our required right hand side. In this way, by considering the left hand side, we have shown that its value is equal to what? Right hand side. Now see the second example. In the second example also, we have to show that value of this left hand side is equal to right hand side. So consider the left hand side. By simplifying it, we have to show that its value is equal to right hand side, means we have to show that its value is equal to what? Minus 1. Minus 1 means we have to simplify it in such a way that all the terms will get what? Cancel, and remaining term should be minus 1. Let us simplify it. Here what is the first term in the bracket? cos square a minus 1. But we know that 1 minus cos square a can be replaced by what? Sin square a. Means to apply the identity, we have to take minus common from first bracket. If I am taking minus common, this negative term will become positive and this positive term will become what? Negative, since we have taken minus common. And here keep the second term as it is. only cot square a plus 1 I am writing as 1 plus cot square a. Okay, just we are interchanging these two terms. A plus b can be written as what? B plus a. Now, according to identity, 1 minus cos square a will be equals to sin square a. Here, into keep it as it is, and 1 plus cot square a will be equal to what? Cosec square a. Just simply we are applying fundamental identities here. So, minus keep it as it is, sin square a also as it is, into cosec square. Can I write it as 1 upon sin square? Yes, cosec square a can be written as 1 upon sin square a. Here, after cancelling sin square a and sin square a from numerator and denominator, what is remaining term? Minus into 1 will be equals to minus 1, and which is nothing but our what? Required result. In this way, by considering the left hand side, we have shown that its value is equal to right hand side. See, in the example number 3rd, first we have considered this left hand side, and by simplifying this left hand side we have to show that its value is equal to right hand side. If you will observe both the terms here are in the form of a plus b whole bracket square, and this term is also in the form of a plus b whole bracket square, means we are able to find out its expansion using this identity a plus b whole bracket square, and later on simplifying we will try to get our required result. So which is equals to, now a plus b whole bracket square means a square means sin square theta plus 2ab means 2 sin theta into sec theta plus b square means what we'll get here? Sec square theta, plus now we are finding expansion of this bracket using same identity a plus b whole bracket square. So here a square means cos square theta plus 2ab means 2 cos theta into cosec theta plus b square means what? Cosec square theta. So which is equals to, now if you will observe the right hand side is also in the form of a plus b whole bracket square. So means we have to arrange the term in the form of what? A square plus 2ab plus b square, so that it can be expressed as a plus b whole bracket square. So here first term is 1. So check that after simplifying, is it possible to get 1? Yes, if we are collecting sin square theta and cos square theta, then according to identity we will get what? 1. So we are trying to get 1 here. Later on we will try to get the second term means 2ab also, and third term means b square also, isn't it? So here first collect the terms of sin square theta and cos square theta. Now if you will observe the second term is what? 2ab. So here two terms of 2 are there. So if I am taking 2 common from these two terms, so here its coefficient is sin theta into sec theta, and here coefficient is cos theta into cosec theta. Simply we can say that we have taken 2 common from these two terms, isn't it? So that after simplifying it we will try to get twice a plus b here, and last required term is what? B square. So collect these two terms here, sec theta and cosec theta, sec square theta and cosec square theta, sec square theta plus cosec square theta. So already we have written all these terms here, isn't it? So now according to identity its value is equal to 1 plus, now 2ab, a means 1 and b means cosec theta into sec theta. To get that result we are simplifying this expression. To simplify it, replace sec by what? Sec can be replaced by 1 by cos, and cosec can be replaced by 1 by sin. First we will convert it in terms of sin and cos, and later on we will try to convert it in terms of what? Cosec and sec. So observe here, keep this 2 as it is. I am not disturbing to sin theta. This sec can be written as what? 1 upon cos, means simply we are taking sec in the denominator. Again if we are taking reciprocal of cos, we will get sec theta. Again here cos theta, keep it as it is, and this cosec can be written as 1 upon sin. So 1 upon sin theta, isn't it? Plus here also this because we will require multiplication of these two terms, so means we have to replace plus by what? Multiplication, because our last term should be what? B square. What is b here? Cosec theta into sec theta, and b square means cosec theta into sec square theta. Here addition is there. Just to convert it into multiplication, we are converting it in terms of sin and cos. So sec square theta can be written as 1 upon cos square theta. and cosec square theta can be written as 1 upon sine square theta. So which is equals to 1, keep it as it is, plus also as it is. Take the cross multiplication. Let us see what we'll get. Sine into sine is sine square theta, plus cos into cos is cos square theta, and in the denominator sin theta into cos theta will be sin theta into cos theta. Just simply we have taken cross multiplication. Here also take the cross multiplication. So what we'll get here, sin square theta plus cos square theta into 1 is cos square theta, and in the denominator sin square into cos square will be sin square theta into cos square theta. Now if you will observe this numerator, sin square theta plus cos square theta according to identity can be replaced by 1, and here also sin square theta plus cos square theta can be replaced by 1. So here first term is 1 plus twice keep it as it is. If I am replacing it by 1, so what we will get here? Here twice keep it as it is. Twice keep it as it is. So here we will get 1, and in the denominator sin theta into cos theta plus again 1, and again denominator is what? Sin square theta into cos square theta. So which is equals to 1 keep it as it is plus 2 also as it is. What is reciprocal of sin? Will be equal to cosec theta. Reciprocal of cos is what? Sec theta, plus again reciprocal of sin is what? Cosec square theta. Cosec square theta, and reciprocal of cos is cos square is what? Sec square theta. And if you'll observe this expression, check that is it in the form of a square plus 2ab plus b square? Yes. So and it can be written as a plus b. B is what here? Cosec theta into sec theta. Again, if you are finding its expansion considering this term as a and this term as b, and what result will get? A square plus 2ab plus b square, means this 3 term is nothing but the expansion of 1 plus cosec theta into sec theta whole bracket square, and which is nothing but our required right hand side. In this way, considering left hand side, we have shown that its value is equal to right hand side. See in the example number 4th, what we have to show that the value of 1 plus cot theta minus cosec theta into 1 plus tan theta into sec theta, tan theta plus sec theta is equals to 2. So if you will observe the given expression, tan, cot, sec, cosec, means 4 trigonometric functions appears, and simplifying this expression we have to show that its value is equal to 2, means every trigonometric function should have to get eliminated, and our answer is in what number? Simplification becomes very easy if we are converting this expression in terms of what? Sine and cos, because we know that every trigonometric ratio can be converted in terms of what? Sine and cos, and simplification becomes very easy. That's why I am converting it in terms of sine and cos. 1 keep it as it is, cot theta can be replaced by what? Cos theta upon sin theta, minus keep it as it is, cosec can be replaced by 1 upon sin theta, into 1 plus tan can be replaced by what? Sin theta upon cos theta, and sec can be replaced by 1 upon cos theta. So just now I had told that every trigonometric ratio can be converted in terms of sine and cos. So we have converted this whole expression in terms of sine and cos. So which is equals to, now if you will observe the first bracket, denominator of 2 term is sine. To get sine in the denominator, we have to multiply here by sine, and since we are multiplying to denominator by sine, so we have to multiply to numerator also by what? Sine. So I am multiplying here by sine theta, so that denominator of every term becomes what? Same. So if I am multiplying to denominator by sine, so here in the numerator also we have to multiply by sine. So 1 into sine is sine, here already sine is there, not necessary to do any type of adjustment. Here also sine is there, keep 1 as it is. Just simply here I am multiplying to numerator and denominator by what? Sine, so that denominator of all the terms will become same, and if denominator becomes same, we are able to take addition subtraction of numerator. If you will observe the second bracket also very carefully, denominator of 2 term is cos. To get cos in the denominator, we have to multiply to numerator and denominator by what? Cos. If I am multiplying to numerator and denominator of first term by cos, here we will get cos theta, and denominator of every term becomes same, plus sin theta plus 1 keep it as it is. So which is equals to Now I am taking multiplication of these two brackets. In the denominator, see what we'll get. Sin theta into cos theta will be equal to sin theta into cos theta. Observe the numerator very carefully. What is the first term here? Sin theta plus cos theta. Here also first term is what? Sin theta plus cos theta. Sin theta plus cos theta. And here second term is what? Minus 1, and here what? Plus 1. Means if you observe the terms, it is in the form of a minus b into a plus b. And we know that a minus b into a plus b is what? A square minus b square, according to identity, that a plus b into a minus b is equal to a square minus b square. So here a minus b into a plus b will be equal to a square. A square means what? Sin theta plus cos theta whole bracket square minus b square means 1 square. Just simply terms are in the form of a minus b into a plus b. Its product will be equal to a square minus b square. So which is equals to, again we are finding expansion of this bracket applying a plus b whole bracket square identity. What result we will get? A square plus 2ab plus b square. A square means what? Sin square theta plus b square. B square means what? Cos square theta plus 2ab. 2ab means 2 sin theta into cos theta. Minus, keep it as it is. What is square of 1? Will be equal to 1. And in the denominator, sin theta into cos theta, keep it as it is. Now according to our fundamental identities from trigonometry, so this sin square theta plus cos square theta can be replaced by what? 1. So substitute its value is equal to 1 plus 2 sin theta into cos theta, and this minus 1, keep it as it is. Just simply I am replacing this term by its value 1. In the denominator, sin theta into cos theta, keep it as it is. Now if you will observe the numerator very carefully, this plus 1 and minus 1 will get cancelled. After cancelling plus 1 and minus 1, what is the remaining term in the numerator? 2 sin theta into cos theta, and term in the denominator is what? Sin theta into cos theta. Now after cancelling sin theta and cos theta from numerator and denominator, what result we will get? 2, and that is nothing but our right hand side. Means in this way, considering left hand side, we have shown that its value is equal to right hand side. Now see the example number 5th. In this case, this is the left hand side which already we have considered, and simplifying it, we have to show that its value is equal to what? Right hand side, that is sec theta into cosec theta minus 2 sin theta into cos theta. So first let us simplify it, and after simplifying let us try to get our required result. So here in the numerator, tan cube theta is there, so we are not disturbing to numerator, but if you will observe the denominator very carefully, it is in the form of identity 1 plus tan square theta, and we know that value of 1 plus tan square theta is what? Sec square theta, plus here also cot cube theta, keep it as it is, and 1 plus cot square theta will be equals to cosec square theta. Just simply we have applied the identity. Now we are converting this whole expression in terms of sin and cos, because in our required results term of sin and cos also appears, and sec and cosec can also be obtained by taking reciprocal of sin and reciprocal of cos, isn't it? So here this tan cube can be written as what? Sin cube upon cos cube, isn't it? So tan cube theta can be written as, this tan cube can be written as sin cube upon cos cube, and this 1 upon sec, remaining term is what? Sec. Sec is in the denominator. If we are taking its reciprocal, and we know that reciprocal of sec is what? Cos. So here we will get cos square theta. Reciprocal of sec square is what? Cos square. Just we have converted tan cube also in terms of sin and cos, and the sec square also in terms of cos. Now cot cube, cot can be written as what? Cos upon sin. So cot cube can be written as cos cube theta upon sin cube theta, cos cube theta upon sin cube theta, and cosec, if we are taking reciprocal of cosec square, we will get what? Sin square theta. Just we are using interrelation between trigonometric ratio. Now check which terms will get cancelled. Here cos square and cos square from denominator will get cancelled. So keep this sine cube theta as it is. If we are cancelling cos square from numerator and denominator, here cos square will get cancelled, and if we are cancelling cos square from cos cube, so remaining term is cos theta. Plus here also keep cos cube theta as it is, and if we are cancelling sine square from numerator and denominator, what will get here? Sine theta, because here sine square will get cancelled, and from sine cube, if we are cancelling sine square, then remaining term is what? Sine. Now take the cross multiplication. Let us see what we'll get here. Sine theta into sine cube theta is sine theta raised to power 4. Again, cos into cos cube will become cos theta raised to power 4, and in the denominator sine theta into cos theta. Sine theta into cos theta. Now we are making the use of one identity to simplify this numerator. Now try to understand that identity. We have one identity. We have one identity that a plus b whole bracket square. What is the value of a plus b whole bracket square? That is a square plus b square plus 2ab. Now this plus 2ab on this side will become what? Minus 2ab. Just simply we are using transformation. Plus 2ab we have taken on this side, it will become minus 2ab. Now we are trying to arrange this term in the form of a square plus b square. Already plus is there. Now this sine theta raised to power 4, can I write it as sine square theta raised to power 2, and cos theta raised to power 4 can be written as what? Cos square theta raised to power 2 according to laws of indices, which is also called as laws of exponent. Now here 2 into 2 will become 4, and here also 2 into 2 will become 4, means cos theta raised to power 4 can be written in this form. In the same way, sin theta raised to power 4 can be written as square of sin square theta. In the denominator, sin theta into cos theta, keep it as it is. Now consider this term as a and this term as b. Consider this whole term as a and this whole term as what? B. Now it is in the form of a square plus b square, and according to this identity, a square plus b square can be replaced by what? A plus b whole bracket square minus 2ab. So a plus b whole bracket square, a means what here? Sin square theta, plus b means what here? Cos square theta minus 2ab. A is here sin square theta and b is nothing but what? Cos square theta, divided by, in the denominator, sin theta into cos theta, keep it as it is. Just we are simplifying this numerator, applying this identity. Here we have considered this whole term as a and this whole term as what? B. Now according to identity, here square is there, keep this square as it is. Now according to identity, sin square theta plus cos square theta is equal to what? 1. So replace this whole term by its value 1, keep this square as it is, minus 2 sin square theta into cos square theta, keep it as it is. In the denominator, sin theta into cos theta, keep it as it is. So which is equal to, what is square of 1? 1. And here minus 2 sin square theta into cos square theta, keep it as it is. Here two terms are there in the numerator. I am dividing to both the terms separately by sin theta into cos theta. So sin theta into cos theta minus 2 sin square theta into cos square theta divided by sin theta into cos theta. Just divide separately to both the terms by denominator. So which is equal to, now what is reciprocal of this sin? It's cosec, and reciprocal of cos is what? Sec. Reciprocal of sin is cosec, and reciprocal of cos is what? Sec theta, minus 2, keep it as it is. Here sin and one sin from numerator will get cancelled. Again cos and one cos from numerator will get cancelled. Now here cosec into sec can also be written as what? Sec into cosec to get our required result. So sec theta into cosec theta minus 2 sin theta into cos theta, and this is the required result which we have to prove here. In this way we have shown that left hand side is equals to what? Right hand side. Now observe the example number 6. In this example we have to show that the value of this left hand side and is equal to what? Right hand side. So see, to solve this example, we have to make the use of identities, proper use of identities. Three types of example can be constructed which can be solved using same method which we are discussing in this example. This example is in terms of what? Sec and tan. So in this example, we have to use the identity that sec square theta minus tan square theta is equals to 1. If the example is in between sin and cos, then use the identity that sin square theta plus cos square theta is equal to 1. And if the terms are in the form of cot and cosec, then use the identity that cosec square theta minus cot square theta is equal to 1. Isn't it? I just stand this example is in terms of sec and what? Tan. So we are using which identity? Sec square theta minus tan square theta is equal to 1. So try to understand. Only one example is given in this exercise, but three different examples can be constructed. So here we have to prove that this value of left hand side is equals to what? Right hand side. So if we are considering left hand side, so lot of efforts we have to take to show that its value is equal to what? Right hand side. That's why we are using some alternate method. Try to understand it very carefully. So we have to prove that this left hand side is equals to right hand side. That is to prove that TPT can be read as what? To prove that 1 upon sec theta plus tan theta, and this minus term on this side will become plus 1 upon sec theta minus tan theta is equals to, on this side 1 upon cos theta, keep it as it is, and this minus term on this side will become plus 1 upon cos theta. So if we are able to show that this left hand side is equal to right hand side, then what we'll get? This, after showing that this left hand side and right hand sides are equal, तो फिर क्या करना है हमें? टर्म्स इंटरचेंज करने हैं. ये प्लस टर्म इधर आके माइनस हो जाएंगे और ये प्लस टर्म इधर आके माइनस हो जाएंगे, and we will get this result. Means to prove this one, we have to prove this one, and that's what we have written here. We have to prove this left hand side is equal to right hand side. That is to prove that this left hand side is equal to what? Right hand side. अगर हमने ये प्रूफ करके बताया, इसका मतलब इनडायरेक्टली ये प्रूफ हो गया, क्योंकि इसमें टर्म रीअरेंज किए तो हमें अपना रिक्वायर्ड रिजल्ट मिलता है. ऐसा हमने ऑलरेडी यहाँ पे लिखा है. वी हैव टू प्रूव दैट दिस लेफ्ट हैंड साइड इज इक्वल टू राइट हैंड साइड. दैट इज टू प्रूव दिस वन. So which is equal to, so on this side check that denominators are same. So what is the addition of numerator? 1 plus 1 will be equal to 2 upon cos theta. If denominators are same, we are taking addition of numerator, means we have to show that value of this expression is 2 upon cos theta. If we are able to prove this, means we can say that we will get the proof of given example also. So now we are considering the left hand side. So consider 1 upon sec theta plus tan theta plus 1 upon sec theta minus tan theta. Just simply we have considered this left hand side. Now we are simplifying it to get our required result, means right hand side. So let us simplify it now. Take the cross multiplication. So sec theta minus tan theta into 1 will be equal to sec theta minus tan theta, plus sec theta plus tan theta into 1 will be equals to sec theta plus tan theta, and in the denominator see what we will get? Sec theta plus tan theta into sec theta minus tan theta. Now after taking cross multiplication, if you observe the numerator here, minus tan theta and plus tan theta will get cancelled, and what result we are getting? Sec theta plus sec theta will be equals to 2 sec theta, and terms in the denominator are in the form of a plus b into a minus b, and what is the product of a plus b into a minus b? Will be equals to a square minus b square. A square means what result we will get here? Sec square theta minus b square. B square means what? Tan square theta. In the numerator 2 sec theta, keep it as it is, 2 sec theta as it is. In the denominator, according to identity, sec square theta minus tan square theta will be equals to what? 1. So 2 upon sec 2 sec theta upon 1 will be equal to 2 sec theta, not necessary write 1 in the denominator. In the numerator 2 keep it as it is, and sec theta can be written as what? 1 upon cos theta, and check that is it the result which we have to show. Means if we are able to show that this left hand side and right hand side are equal, after simplifying it we will get our required result. That part already we have written here. That's why we can say that hence proved. Now in this way we have solved how many examples? 6 example from question number 15. Again 6 examples are remaining. Remaining 6 example we will discuss in the next video. If you like the video, please subscribe the channel if you are new on my channel.